Okay, so I can tell that hopefully that the day that you guys are okay with inequalities because I haven't had any question about inequalities. Alright, but in any case, if you find that you cannot derive the right answer after trying at home, do not hesitate to come and approach me, okay? Alright, so what we're going to do now is we're going to go through a set of exam questions from 2013. Yes, okay? So we go to 2013. There will be a question, something that looks like this. Okay, you are given an open loop transfer function, or open loop forward transfer function, GS, equals to K over S plus A. Do I have this in the middle? I may have already uploaded. Okay? So you are free to copy if you want. Alright? The closed loop transfer function is just Kg over 1 plus Kg. Simplify, you have K over S plus A plus K. Okay, so that's the first thing you do, you form the closed loop transfer function. Second thing you do, okay, write down the characteristic equation, S plus A plus K equals to 0. Okay? Alright, so usually this is what you do. Alright? Okay? But in the question, we are asked to determine the range of K for which systems with the following characteristic equations are stable. So you are already given the characteristic equation. Alright? Okay? So the characteristic equation has already been provided. So this is your AS. Okay? So AS equals to S squared plus 2S plus B. Alright? So just recognize this. And then refresh your memory. What is A2, A1, and A0? A0 is the coefficient for S to the power 0. A1 is the coefficient for S. A2 is the coefficient for S squared. Okay, so from here, A1 is 1. Sorry, A2 is 1. A1 is 2. And A0 is K. Okay, for second order, the criterion says I wrote more than what is required. Okay, for first and second order systems with characteristic equation A1S plus A0 equals 0 and A2S squared plus A1S plus A0 equals 0, requirement for closed loop stability is simply AI bigger than 0, meaning your A0 bigger than 0, A1 bigger than 0, A2 bigger than 0. So answer, K bigger than 0. Okay? Just need to tell me K bigger than 0, that's all. Right? The rest is just for your information. Okay? Next, we move on. S power 3 plus 4 plus K, S plus 16K equals 0. Okay? Tell yourself. This is already the characteristic equation. This is already your AS. Okay? For third order system, AS, A3S to the power 3 plus A2S power 2 plus A1S plus A0. Okay, obviously, here is there any S squared? No. So A2 is 0. Is it positive? What's the definition of positive? Must be greater than 0. So is this positive? No. Okay, so answer is the system is unstable for all K since A2 is 0. That's all. Okay, so this is a tricky one. Next, we move on. S power 3 plus 4S squared plus 4 plus KS plus 8K equals to 0. Tell yourself that this is third order. Okay, A0, 8K, A1, 4 plus K, A2, 4, A3, 1. For stability, all coefficients must be bigger than 0. So your A0 is AK bigger than 0. A1 4 plus k bigger than 0. We don't care about 4 and 1 because they are definitely positive. Okay, second condition. Alright, second condition is your A1 and A2. Okay, must be bigger than A3 and A0. If you cannot remember, the inner product must be bigger than the outer product. Okay? Say again, inner product 4 times 4 plus k must be greater than the outer product 1 times k. Got this? Yeah? Okay? Simplify. So I hope you can simplify this. You end up with k from 0 to 10. Anybody who cannot simplify this? I just need one person to raise your hand and I will explain. You want me to explain this? Yeah, I got one hand, okay? Okay. Alright, so what do we have? A bigger than 0. 4 plus k bigger than 0. And here you have 16 plus 4k bigger than 8k. Alright? This is obviously k greater than 0. This is k. What? Huh? Bigger than or smaller than minus 4? Bigger than minus 4. Right? Oh, obvious, right? Because between minus 3 is bigger than 1. Minus 2 is 3. Okay? And this one? 4k less than 16, which also means that k less than 4. Okay? Then you draw 9 minus 4, 0. K bigger than 0. Okay? K bigger than minus 4. Okay? And then k less than 4. So, find the common range. Okay, answer. K must be from 0 to 4. Okay? Alright? Okay, so let's move on. Any questions? Alright, just find a common range. You need to satisfy all the conditions. Alright. So far so easy, right? Okay, the last question. Yes. Okay, are you ready to continue? Alright, s to the power of 4 plus 2s cubed plus 4s squared plus 4 plus ks plus 8k equals to 0. This is your characteristic equation, and as is this. Okay, so tell yourself that a4 is 1, a3 is 2, a2 is 4, 4 plus a is a1, ak is a0. Alright, next you form your group array. Okay? A4. What you're going to view is A4, A3, A2, A1, A0, nothing. Okay? So A4, 1. A3, 2. A1, 4. A4, A3, A2, okay? A4, 1, A3, 2, A2, 4, A1, 4 plus A, A0 is AK. And then we have enough coefficients to go around, so this is okay? A4, A3, A2, A1, A0. Alright? Then look at this element 2. What I do next? 2 times 4 minus 1 times 4 plus A over answer if you simplify this 4 minus K over 2. For this part, same here, you look at 2 times AK minus 1 times nothing over 2. Okay, then we look at this part. Okay. Alright, 4 minus K over 2 times 4 plus K minus 2 times AK or 4 minus K over 2. Alright? Okay, here we take 4 minus K over 2 times nothing. So nothing minus 2 times nothing, nothing. And this one, if you want to continue, you just take this times AK minus this times nothing over this, or just write out A0. It's D9. Okay. So has anybody managed to simplify this? Alright, so look at this. A minus B times A plus B, what do we have? Square minus A square over 2 minus 16A over 4 minus A. Okay, so 4 square minus A square minus 32A 4 minus A minus A square minus 34A. Alright. Okay. So from the Routh-Hurwitz stability criterion, how many conditions do we have? First, all coefficients must be positive. And then the first order of the group array, which is this column. All elements in this column must be positive. So 1, is it positive? Yeah? No. 2, positive? No. So when you look at this one, bigger than 0. This one bigger than 0. And this one bigger than 0. Okay, so to make it easier, let us just write down all the conditions. Okay, so for first order system, all coefficients must be positive, right? So this is your first order. This is your fourth order. Okay, all coefficients must be positive. So 1 is positive, 2 is positive, 4 is positive. Alright? A0 must be bigger than 0. So A bigger than 0. A1 must be bigger than 0. So 4 plus A bigger than 0. Column 1, row 3. 4 minus A over 2 is bigger than 0. Column 1, row 4, just simplify already. Minus A squared minus A 16, 4 minus A. Bigger than 0. Column 1, row 5, bigger than 0. Okay, now simplify. AK bigger than 0, A bigger than 0. This bigger than 0, A bigger than small. This one says A less than 4. This one straightforward, A bigger than 0. Okay, this one. What do you do with this? You need to get rid of the denominator, right? So you can only multiply the denominator if the denominator is positive. So if this condition holds, that k is less than 4, the denominator here is positive. Okay, so you can get rid of it. Okay, so this tells you that minus k squared minus 32k plus 16 must be greater than 0. Okay? So next, you solve this quadratic equation. We have k squared plus 2k minus 16 equals to 0. Okay, this gives you minus 32 plus minus square root b squared minus 4ac equal to 8. Which is minus 16 plus minus 4 plus 17, which is 0.4924 minus the equal. Okay, there it is confusing. You've got two answers, right? Now what you need to do is to punch into your calculator. Okay? So if you punch in your calculator, you'll realize that the solution to this is k must be smaller than 0.492. Just punch into your calculator and see that it equals for these numbers. Okay, next, summarize. Okay, your conditions: 0, minus 4, 0.4924. Okay, k bigger than 0. K bigger than minus 4. K smaller than 4. K smaller than 0.194. Okay, so the common range is here. Alright, and for closed loop stability, k is equal to 0.49. Okay? Alright, so if you cannot do this, okay? Any questions? Anybody who cannot see this? Can you all see this? Yes or no? Yes, okay. Alright, as I said in the last lecture, there are a set of tutorial questions which are in your, are they in your notes?
No.
I think they should be, if not, download from below. Okay, altogether you have all the tutorial questions for the whole course. So I'm going to tell you this, alright? General control concepts, which we covered in the first lecture, or things that you ought to know from mathematical modeling and simulation, are question 1 to 9. If you wish to practice what you learned today, the Routh-Hurwitz questions are from question 10 as well.
No answer.
So take for instance, look at question 10. Use the Routh-Hurwitz stability criterion to determine the range of A, for which systems with the following characteristic equations are stable. So they already gave you AS. Right? Straightforward. Third order, fifth order. You go home and alright, solutions are provided.
Where?
The last page. Okay, so you have the solutions. Alright. So this is question 10. Question 11, you are given a transfer function. Okay, so from a transfer function, you work out the characteristic equation. Alright? Okay, and then question 12, which is the last question for Routh-Hurwitz. You are given a system GS, this, which is the third order. But what is different is that the controller is no longer purely proportional. Alright, you have a PI controller, a proportional particular controller. So what is a PI controller? A PI controller will have a proportional term, AP, plus an integral term PI over S. Okay? With negative unity feedback gain. So you are drawn a figure. Yes. Okay? So this is your GS, which is your plant system. This is your PI controller. They are wired with negative feedback like this. Okay? If this determines the closed-loop transfer function. What is the closed-loop transfer function? Kg over 1 plus kg. So here it's not just K, right? Alright. times this whole block over 1 plus this times this. Very simple. Okay? So after you do that, use the Routh-Hurwitz stability criterion using the ratio K. Meaning you look at the denominator, and then you use the Routh-Hurwitz stability criterion to check this one. Alright? Any question on this? No? Okay, good. So if that's the case, you guys practice. Alright, I will end the lecture. Okay, let's see you.